Thank you so much. And I think we are perfectly in time now to hand over to Burkhard Schaefer. So he will be presenting on a little bit deeper dive on SiLA and AnIML as a non-proprietary cloud connectivity and data management enabling what? Digital transformation. So I think here we are closing the loop for this entire conference, which is very nice. And let me just quickly introduce Burkhard. He is board member and head of partnering of the SiLA Consortium. He's a certified computer scientist and managing director of BSSN Software. And prior to founding BSSN Software, he was already working with the standardization of device interfaces and data formats at the Los Alamos National Laboratory and the National Institute of Standards and Technology. Today, his focus is on strategies for consistent data management and integration. And he's a member of ASTM, where he pioneered AnIML technology as an architect. And as said, he's also a member of SiLA's board of directors. So over to you, Burkhard.
Thanks, Daniela, for the kind introduction. And thank you for the invitation to present today. So I think we've heard a lot about leveraging the cloud in achieving many of our informatics goals. And it has become one of the tools of choice that we use when we want to get to an agile deployment methodology, quickly scale up capacity, and leverage infrastructure or components or software as a service. But one thing that is sort of still there is all of those instruments that we have on premise, and we can't get those in the cloud, right? Because they don't fit through the pipe. So how do we get all of those instruments to play nicely within such a cloud environment? And we've had a couple of things that have happened recently. Yeah, we have a couple of Internet of Things applications from a number of vendors, and they have provided options for connecting these instruments. However, all of those vendors had to come up with their own approach of how to do the connectivity. And, you know, if we think about that, that's actually not something where I would want to spend my time in defining yet another cloud protocol, you know, for the next vendor. So, so here, I'd like to take our attention to some work that's been going on in the SiLA Consortium and in the AnIML working group at ASTM that are combining communication protocol and a data format to address non-proprietary cloud connectivity and data management to help embrace those technologies and push our digital transformation initiatives. And so this is based on some very recent work, and today is actually the first time where we are unveiling that. So consider yourself privileged. Thanks for being here. So I think we've all heard these ideas. Yeah, standardization, it's great, and standards are wonderful. Let's have as many of them as possible. But there is also a certain level of uncertainty around standards. And we face some common questions that we as stakeholders and also we as members of the standards community need to take very seriously. So some of those questions you find here, and some of those you may have asked yourself already. Are our lab standards complex? It sounds like there are so many complex things behind them, and are they all that expensive? And how mature are the different approaches? Is this something that that is ready for use? And does using standards make my projects easier, or does it make them more unpredictable? So is this actually a risk, or is this a help? And then we have to also say, maybe a proprietary alternative approach could be faster and cheaper to get where I want to go. And if that's the case, that's also what I should do, right? I should not use standards just because they are the hot thing, and I should be doing that. And And so we need to have an easy way in, and we need to make sure that the standards cover those use cases. And I think here with the cloud connectivity and this distributed data management, we have a really interesting use case that calls for a cloud native approach to do those types of things. And for that to work, standards need to scale. They need to scale so that they are easy to use, they are easy to understand, and they need to be easy to adopt using proper tooling, so that I don't have to write all the tools myself, but I can leverage existing tools. And there I want to be able to get started easily without having to invest a lot and to have a huge project around it. And then I start small, but then I scale from a small deployment to a potential large one, which could even be global. And it would help if we had that maintained and supported by an established standards body that has done this for a while, so that we also have stability around that. And so, as you can see, standards are not just a technical problem that is being solved, but there are also some business drivers around it, and there is the question of sustainability, and there is the question of approachability. And for the cloud enablement use case, we want to look at two things today, which is, as you've probably heard already, if you're thinking communication standards in the lab, SiLA is front and center. And if you're thinking data exchange, AnIML is the most mature option that's out there, with a track record since actually 2004. And this is now looking at how we can adopt these to further our digital transformation purpose. And so we'll look at adopting and scaling SiLA 2 and AnIML, and we'll explore how those two standards can be applied to different scenarios. And for that, we've got two things here. The first one is cloud connectivity. So finally, standards-based IoT connectivity for instruments. And not just small sensors, right? Really heavy-duty machinery, HPLCs, NMRs, plate readers, bioreactors. And number two, how to actually use this in an enterprise environment where we also have data in the picture, and we have a heavy-duty LIMS, and we have a heavy-duty chromatography data system, and we have tens of thousands of users, and we want to show how we have successfully applied these principles to meet a concrete use case. So let's start with the first case study, which is kind of the premiere for today: cloud connectivity, standards-based IoT capabilities for instruments. So why is that important? First of all, when we talk to an instrument, I have a system, I want that to talk to an instrument, whether I am a LIMS or whether I'm an ELN or a process management system. I need a way of talking to it. I need a way to reach it. And ideally, I have a network that allows me to do that. So it must be reachable using that network. And that works well if I'm on the same network as that instrument. It will get difficult, though, if I am using an isolated lab network, right? And then I want to host my application outside of that isolated lab network. Then I have firewalls to cross and so on. And it gets even worse if my application lives in the cloud, because then, I mean, how do I get all of that to work with all of those disconnected network segments? And so within the SiLA Consortium, we got together and we thought there needs to be a cloud native approach to solve this. And this is also a pre-competitive undertaking, because we all have that problem. We have that problem whether we are in the end user community and we want to connect our labs, and we have that same problem if we're in the vendor community. So can we do something that is pre-competitive and delivers a best of breed cloud native approach to that? And so we looked into that. And so we said, okay, what are the scenarios that we want to cover? And we start with the lab network scenario. So you can see here we have our network universe, and in that universe we have a few things. So we have the lab network, Then there is a firewall, and then maybe we have a corporate network that is not managed by lab IT, but corporate IT. And then I have another firewall, and then there is the internet. And probably there are, if I have multiple sites in my organization, I have a couple of corporate networks that are linked somehow, and lab networks that are linked somehow to the corporate network with a certain well-defined set of policies, and so on. Yeah, and this calls for nightmares. So we typically settle for the least controversial deployment approach. So we have the instrument in the lab network, and we put the client software that wants to talk to it right next to it onto the same network segment. That way, if my client, let's say a LIMS and an ELN, wants to send a sample list to the instrument, it can open a connection, for example, a SiLA connection, which is just HTTP2, and it will reach that instrument, and it can send it commands, get data back, and so on. So this works, right? And we find ourselves very much drawn to this design paradigm, right? We want to put the client and the instrument on the same network segment, and then we are fine. However, life is usually more difficult than that. So let's become a little bit more realistic, and let's bring in the evil corporate network scenario. The evil corporate network scenario means that we want to host our application outside of the lab network, which for a LIMS is actually quite typical, because that LIMS serves multiple labs. Yeah, and then why should I put it onto this individual lab network? And yeah, it's much easier to maintain if it's on the corporate environment. And so people typically settle for that. But if I want to connect from that LIMS to a resource that's on the lab network, and that could be my instrument, I am in trouble. Yeah, because that connection is typically intercepted by the firewall, and usually IT departments are very strict about what they allow through this. So, yeah, the corporate network cannot access the lab network, so my connection will be blocked. Then I have to start negotiations with IT and have really proper security around that, and this is not easy to do. And I need to do that for every instrument that I have here. So for every individual connection, I end up having to solve this problem. And so that doesn't scale. So let's make it even worse. Let's actually say we don't want to host our client application in the corporate network, but we like the cloud. And as we've all heard today and yesterday as well, you know, in pretty much every talk there was a mention of, yeah, we're hosting this in the cloud. Yeah, this is at AWS, this is in Azure, and yeah, previous speaker, a wonderful example. And we want to be able to leverage that technology. But hey, yeah, now we have the same problem. That cloud-enabled piece of software cannot reach the corporate network because obviously it's firewalled off. And well, obviously, if I want to go all the way to the lab network, there is even less possibility to do that. So how can I get these things to talk? And now at that point, every vendor rolls up their sleeve and comes up with their own solution. And everyone has to invest again and again and again into something that we could share instead. If we had one proper protocol design of how to solve this problem once and for all, we'd be much better off. And so let's take a look at what the IoT world is doing elsewhere. And by the way, what my laptop and my phone are doing at home as well. But because I have that same problem, right? My router is my firewall, and no one can connect from the outside in. However, we can reach out, right? If I am within the network and I want to reach an outside resource, let's say it's my web browser that's trying to connect to a website, hell yeah, that's fine. Yeah, there is very little resistance to making that stuff happen. So what if we took the idea of saying, couldn't the instrument be the one that initiates the connection? Rather than us connecting from the outside in, well, the instrument is on the inside and it's under good control. And it knows what's okay and what's not okay in terms of remote controlling it. And if the instrument was the party to initiate the connection, that would be much, much easier. And it's a simple idea, and it's an idea worth pursuing. So we did, and we thought, let's apply this approach to the different scenarios. So what if there was an extension to the SiLA standard that actually allows not only the client to initiate the connection to the service, the instrument, but actually having the service open the connection to the client. Yeah, and all we do is we reverse the parties. Who is the one to initiate the connection? Yeah, but then it's still the client that's in charge. So it's still the LIMS that is sending the commands. It's still the ELN that sends the commands. We're just using this this flip in roles to facilitate the creation of the connection. And obviously the instrument knows which connection to open. So there is no way that someone else can intercept and can actually connect to the instrument from the outside, because it's actually the instrument that has that thing under control. So from a security perspective, it's a very elegant approach. And so now, since it's the instrument that opens the connection, having the LIMS and the ELN and the MES on my corporate network is actually fine. And that's beautiful. So suddenly I can deploy it where I want, and I can still have a seamless integration with my instruments. Now, let's take the other horror scenario where the instrument moves to the cloud. Well, that scenario doesn't look as scary anymore, because we can now do the same thing. We initiate the connection on the instrument, and then we have the client receive that connection, and then it's the client that performs the control. And if there is a disconnect, well, the instrument will notice and just reconnect, and then we are back in business. So we call this the service-initiated connection, where any SiLA service, whether it's an instrument or whether it's a chromatography data system or whether it's some other service, can now not only receive connections, but it can also establish connections and then wait for commands. And this is a new capability that's being added to SiLA 2. And that is allowing the connection to be initiated by the instrument and not only the client. It includes secure encryption and authentication, and it allows the instruments to be firewalled. And if we apply that approach, we enable standards-based IoT in the lab. And we no longer have to come up with vendor-specific or project-specific approaches to do that, because we all have the same need, right? And this allows us to place applications where they should be, whether they are in the lab network, whether they are in the cloud, whether they are in the corporate data center or at an outsourcing provider. I can pick the hosting location based on its merit. And by the way, all of my existing SiLA commands will continue to work. And also the integration with AnIML will continue to work. It's supported by the SiLA 2 reference implementations. And the beautiful thing is that a developer who is using those implementations will get this additional feature without having to do a thing. So this is not even a single line of additional code that needs to be written, because it's baked into the SiLA libraries. So from an adoption perspective, it's almost trivial. Well, there's always something to do, of course, in order to get that all set up and deployed. But a lot of work has gone into making this as seamless as possible. So what that gives us is a smart capability to talk to instruments from wherever I am and send them commands. Now, obviously, these instruments also produce data that are being sent back using the same channel. And as you are aware, SiLA is using the AnIML format to push that data over, where SiLA provides the envelope, and AnIML is the XML content of that envelope. You can also store AnIML content as files and so on, but obviously also use it in such a connected setting. And that's where we want to now look at in the second case study. Now we apply this approach of our applications being hosted wherever they may be hosted, and we use that to link a LIMS that happens to live in the cloud with a chromatography system in a global enterprise environment. And for doing that, we're using the CDS interop initiative, which you may be familiar with. As a recap, it's a joint initiative between SiLA and AnIML to deliver bidirectional integration standards for chromatography data systems. And that gives us two things: SiLA feature definitions, so what do the commands look like, and AnIML technique definitions that say, what does the data look like? and it's being built with customer and vendor participation and used in real-life project with the goal of providing robust fileless interfacing that allows low-touch integration without a lot of work with LIMS and ELN, but in a way where a file never touches the disk, where we have proper data integrity and traceability. So if you are familiar with the traditional integration approach, typically you have these things where a LIMS writes a work list to a transfer folder, and then the instrument software monitors that transfer folder for new work list list files and picks it up, and hopefully that file is ready. And yes, I have to deal with that strange format. Then the instrument does its work. It exports a proprietary results file into that folder, which in turn is monitored by the LIMS. And there is a lot of friction and complexity and things that can go wrong. We have instrument-specific file formats for work lists and for the results. Those formats are sort of fragile, they can change. And while the files are waiting on disk, they could be manipulated. And we never have the absolute certainty if the file is truly complete at the time we pick it up. And so here we have no robust error reporting, and we can do better. And that's where this approach is really helping a lot, where we have a couple of current deliverables out of that initiative. So there are SiLA features which provide groups of commands that I can send to a chromatography data system. And that includes discovering the instruments that are there, discovering and downloading methods, submitting samples and sequences, getting the status of sequences, retrieving results in AnIML format, navigating folders so that I can find the experiments that I want, and work with templates if the CDS supports things like sequence templates or e-workflows. And then there are also AnIML technique definitions that define what the data looks like. So here it includes separation techniques such as HPLC and GC, plus the detector techniques. So both single line detectors and also full scan detectors like UV-Vis, mass spec, and so on are supported with that. And here we have an implementation of that, which is actually using this in an environment where we have a LabVantage LIMS that lives in the cloud and a thermochromeleon enterprise CDS. And we have created a service that is using the Chromeleon SDK and some additional interfaces to integrate tightly with Chromeleon. And that provides a SiLA service interface and an AnIML generator. And you can now treat this CDS as a SiLA service. Whether that lives in the cloud or on-premise doesn't matter anymore, as we've just seen. And we have the LIMS sending SiLA commands, and we have the capability to bring AnIML files back into the LIMS after a run has completed. So this service then returns a complete and traceable AnIML data package that also includes extracted report results. So if you do any custom calculations in a report, you can pick that up as well. It also supports e-workflows, which are the Chromeleon equivalent of sequence templates. And there are a set of extraction fields configured within the LIMS to make sure that the content that's interesting in the AnIML document can be mapped to the result files in LIMS. The beautiful thing here is that no file ever touches the disk in this scenario. This is all HTTP based and not file based at all, which means I can now also ask from the LIMS, what is the status of that sequence? Yeah? And the CDS can tell me. And so the fact that I don't have a file coming back, what does that mean? Does it mean that it simply hasn't been run yet? Does it mean the file got lost? Does it mean, we no longer have those types of questions. Suddenly we have certainty because we're actually communicating. And if you put this together with the cloud native protocol that we looked at earlier, you're getting a very scalable and best of breed integration approach that brings an integration capability with a data management capability and the possibility to solve real world problems. And this project that we see here is actually touching over 10,000 users and is running globally across a 2-digit number of sites. So a very scalable approach, and we got a lot of interesting data points that confirm that this architecture is sustainable. So some lessons learned. What we can clearly see is that we have some real world applications that actually work very well, and I find that very encouraging. And we also see that the communities are active, and we have a rapid growth and new features because of that community engagement. And we are finally ready for the cloud. I mean, we've always been using the cloud, but that's always been the question, like in telco, the last mile. How do I go the last mile to the instrument? And that is that's obviously an interesting topic that I think we're all thinking about a lot. And scaling up to an enterprise environment was possible, also due to the fantastic vendor commitment with the partners that were involved here. And with that, this is kind of to give you ideas how SiLA and AnIML can be an integral part of your journey to the digital lab. And besides those, there is the possibility to also cover a number of secondary use cases, whether it's data analytics, whether it's long-term archival, whether it's collaborating with CROs, CMOs, and so on, with little additional effort, because now, as a pleasant side effect, my data is already standardized and normalized in a common format. And that is then giving me some additional cherries on the cake that make this really sustainable thing. So having said that, thanks so much for your interest in this. And I think we have time for a couple of questions.
Yes, we do, Burkhard, and we do have questions. So Matt from SciNote is asking, what is your view on community-driven open source standardization initiatives like AnIML and SiLA versus proprietary and non-free initiatives, allotrope, ? Will open prevail, or will both approaches coexist?
Yeah, I think the answer to that question is not black and white. I'm a big fan of picking the right tool for doing a job. And if my question is communication, well, there is not much out there except for SiLA that is applicable in the lab domain. And then I can look at it from the data representation perspective. If I'm already working with SiLA, the step to AnIML is very small because they are very interoperable. If we are looking at semantic approaches and we accept the higher cost and the reduced accessibility of the data, you may want to go with allotrope. So it's really depending on the problem we're trying to solve. And then you should do your assessment and pick the tool that does the job. I think there is, we have to make this more fact-based. And I think, as we all saw in the election drama that happened in certain countries, right? It's not all just the election was stolen and there's all this and all that. Let's base this on facts and let's look at what's the best tool for doing that. So very pragmatic.
Okay. Yeah, and Matt is also asking, SiLA 2 sounds fantastic. How do you see the challenge with legacy non-SiLA 2 instruments, as this will be a reality for most laboratories for quite some time?
Yeah, absolutely. And that's always the thing. When we have those new technologies come in, we are dealing with an installed base of equipment and with an installed base of software. What we need to do is make sure that it becomes as easy as possible to integrate that. And this also might influence my choice of ecosystem. So SiLA 2 is just HTTP version 2. Yeah? So it's using something that's very simple and straightforward, just as AnIML is just using XML. And the good thing about both is there are a lot of existing tools that can work with that. And some of those tools could even come from mainstream computing. I can buy things like that from Microsoft or from SAP, and they will work with that. So what you can do is, for example, with SiLA 2, you can take the same approach we took for the CDS, and that is you basically create a wrapper in front of it that then exposes a SiLA interface and an AnIML interface to the outside, but then uses whatever measures it takes internally to talk to the instrument in the background. And that adapter paradigm might do the job for you.
Thank you. We are actually out of time, but maybe we can take one more question, which is from Jérôme Monchal, who asks if you have partnerships with Empower from Waters.
Mm-hmm. Yeah, so that is coming. We have all the necessary things in place to put a similar approach into action for Empower, and that is using the very same mechanism. So ask that question again in a couple of weeks, and we'll have a positive response to that. And Waters has been very supportive to this initiative too. Yeah.
That's very good to hear. Thank you. Okay.